Hello everyone, this is Esfandiar Khaleghi and welcome to another CAD CAE Bootcamp. Within the second session of the CAD using the Siemens NX, we're going to continue with the 3D modeling. If you remember, for the last week, we started working with the Siemens NX, familiar also with the user interface of it, and we started using the 2D modeling technique using the sketches. Also, we started a little bit of the 3D modeling, but just converting 2D sketch to the 3D by the simple features such as extrude or extrude subtract or extrude cut as well. But today we're going to continue with the 3D modeling techniques, and we're going to learn a few more, such as the creating holes, grooves, ribs, creating chamfers, sweeps, shells, and more, which we're going to be covered today. Once we finish that, we're going to have a few tutorials that we're going to work together that are going to upload into the separate video. So let's start the today's session. So let's again start a new file, and if you remember, there was the different methods of doing that. I'm going to use the simplest one. You can click there, or you can use the Control and N. Of course, if you remember from the previous session, even you had an option to go and to just go to the menu file and create a new file. I'm going to make sure that we are into the modeling, and I'm going to create a new model. I'm gonna name it model 1 is fine. Make sure you save in your local drive, so it's really important, and make sure you save on your local drive. Otherwise, if in case you're accessing through the virtual machine, it would be wiped after a few hours. And click OK. So I'm gonna wait the software to load completely. And what I'm gonna do, if you remember, we used to start from a sketch, and in order to do that, we used to click on the sketch, pick up the plane that we're gonna work on. I'm gonna use the default one, which is X and Y, and I'm gonna click OK. So I'm going to make a normal rectangle using the 2 points. I'm gonna make it by the 100 and 50 and click Enter or left click of the mouse. And once I finish, I'm gonna click on the Finish a Sketch. You can see I have a 2D sketch, and I'm gonna extrude it using the Extrude feature. I'm gonna pick up the curve that I have, and I'm gonna extrude it by the value of the 50. Once I'm happy with everything, I'm gonna click OK. So you can see this is as simple as that, which we convert the 2D sketch to the 3D model. And this is what we went through through the last session. But I'm gonna do this one in a different way. If you notice, there was the different stages. First, I created a new sketch. In the sketch, I draw the rectangle. I came out of the sketch and I extruded it. I'm gonna show you a different way of doing that. So let me get rid of the sketch that I've done. And now I'm gonna use a feature called block. In order to have access to that one, if in case, let's say I don't know where it is, there's a really useful tool that the NX has, which is this command section. For whatever feature you're looking for, as long as you know the name of it, you would be able to find it here. Let's search for block. And if I click there, we can see the first one, this is the one that I'm looking for. And if I hold on the mouse on top of it, it shows me that if in case I want to grab the block, I can go to the menu, insert, design features, and click on the block. But basically, it would be quite easier for me if I just search it in here. And you can see here, it's currently hidden. So I won't be able to actually find it in there unless I go to the same route that is mentioned. So I'm gonna click there. And within the block, I would be able to give the length, the width, and the height. So the length was 100, the width was 50, and the extrude height was 50 as well. And I'm gonna click OK, and you can see easily with just one command, I generated the same model that I was trying to do within the different stages. So this is one of the beauty of the using block, if in case you wanna use the block feature. The other feature I wanted to talk about is creating holes. In order to find it, it's quite straightforward. You can see we have it into the feature section and it's available there. So I'm gonna click on the hole. And as you can see here, there are the different type of the holes that is available using the Siemens NX. We have the general hole, we have the drill sizing hole, the screw clearance, the threaded hole, as well as the creating the series of the hole. We're going to go through each individual of them today. With the general hole, it also has a different type of it as well. We have the simple hole, the counterbored, countersunk, and tapered. I'm going to go and learn each of them today. So I'm going to go with the general hole and in the type or form of the simple hole. For creating the hole, you need to have a point in order to have the hole from. So in order to do that, make sure you click on the specified point, and you need to choose the face of where you want to have that point. I'm going to pick this one. So just want to have the point here, and I will click once on my mouse. And you can see the point has been created. If I'm looking for more, I'll just click one more. If I want to have two more, you can see whenever I click on this surface, I will be able to generate another set of point. If I want to get rid of that, what I need to do, I need to go there, right click, and I will be able to delete it there. Make sure it's really important, you have to come out of this stage first, which you can either click on close or you can click on escape. It's the same thing. So what I need to do, I need to go there and I can either click on delete, Control D, or I can come and click on this one. It's the same things. So I'm going to get rid of these points that I created. I'm going to want to only use the first point that I have. So this is how you would be able to create a point. If in case you want to have another point, you can easily go there and just click once in the mouse, wherever you want, and you have the point there. So the other thing is really important is the location of that point. So it's really important to just define it where you want to have it. And you can see automatically I got the 2 points because the auto dimension is active. So let me put it into the corner. I'm gonna change the dimension of these by double clicking. Hopefully you remember this one from the first session. I'm gonna put it by, let's put it 20 and 20. And I'm gonna change this one to the 20 as well. And I'm gonna close this one. Let's bring it to the middle. So I'm gonna change this one to 25. Okay. And once I'm happy with the location of the point, I'm just gonna click on finish. And if you notice, I come out of the specifying the point, but I'm still into the creating the whole feature section. So once I specify the point, there's another option, which is direction of it. So the direction, it can be the normal to the face, so which is normal to this face. I can have it along the vector, and I can pick up, for instance, the vector where I want to have it. In this case, I'm gonna make it as a normal to face. The type, I'm gonna go with the simple first. And now I would be able to define the diameter of it. Let's have the diameter of, I don't know, a 20, let's say. A depth of it, which basically is the depth of the hole, the height of that one. Let me change this one to 40. And also the tip angle of that one. Do you see that? So that's the tip angle. If in case you don't want to have a tip angle, I just put it at 0 and you can see I don't have any tip angle. If you want to bring it back, you just put the tip angle in the amount you're looking for. There's the other value in here, which is called depth 2. So if you notice, the first one is a cylinder bottom, which basically the amounts that I put here, 40, is from here to there. So these values 40, and then I have the 100 degrees for the tip angle. However, the second one is up to the cone tip, which basically from here to the end is 40. So that's really important whenever you're going to create a 3D model to make sure that you're creating it using the correct way of doing that. In this case, I'm going to go with the length of 40 here, and then I will have the tip angle. And of course, the Boolean is a subtract because basically you're removing the material, you're cutting something. So I don't change anything, and it's a subtract. Once I'm happy with everything, I just click on OK, and you can see the hole is being created in here. Let me put it into the isometric. But if in case you want to see what's going on inside the model, what I would be able to do, I would be able to come here to the rendering section and change it to the static wireframe so you can see the inside of the model, how it looks like. And if in case you want to bring it back, you would be able to bring it back to the shapes with edges. So that was the first type of the creating the general hole. Then we create another hole. And this time, still when I'm into the general hole, I'm gonna go from the simple to the contour board. Which basically you can see with the contour board, I have much more dimension that I need to put. Let me again to specify the point. I just click once in here, and I'm gonna click on this surface, and I'm gonna put the location for this point. Right, and I put it between this one and the previous point. I'm gonna put it between these two dimensions. So basically, I'm gonna create new dimensions for it. And what I'm gonna do, I'm gonna go to rapid dimensioning, same as what we used to do for 2D modeling. From this point to the edge, I'm gonna put a value, and I'm gonna put that one as, let's say, put it as the 50, and then I'm gonna put a value between this point and this point, and I'm gonna put this one as the 25 to bring it to the center. Then I'm gonna click on enter. So you can see what I've done. So the 50 and 25 from two directions. Once I'm happy with everything, I'm gonna click on finish. And you can see like before I created the point there. And now within the contour board, you have the different dimensions. Basically, the first one is a seaboard diameter, the diameter on the top. Let me change this one and again put it as a 30, for instance. A seaboard depth, the depth of this one. Let me change this one to 15, for instance. And then the main diameter. So this diameter should be smaller than the seaboard diameter. I'm gonna change this one to 20, let's say. So you can have a look, and you can see this one is 20, the seaboard diameter is 30. And of course, the depth of it, that depth. And I'm gonna put the depth for 20 in here. And of course, the angle of it. Something is really important. That depth is still would be considered from the top, which basically, if I have the seaboard depth of 15, only 5 is remain. So that depth is a total. You can see here that depth is a total. And let me change this one to 35, for instance. And you can see that value will change. Also in here, like before, you have the other options such as the until selected. So if I choose the until selected, I would be able to pick where I want to finish that hole basically. It's the same thing. Even for the simple, we have that option as well. And of course, you have it as the until next, which basically whenever you see a face which is available next, it will go through that. Or of course, I can go through the body, which basically you will have the hole from the top to the bottom. In this case, I'm going to continue with the value, and I prefer to have a full control of the value what I put here. And as before, I can put the tip angle if in case I want it. If I don't want to have that one, I can keep it as a 0. And like before, even once I put the angle, I have the option whether to have it from the cylinder bottom, basically from the top to where I have it, or the total depth as well. And also it still is subtract. And once I'm happy with everything, what I need to do, I just need to click on OK, and you can see I created a the contour hole basically. So the first one was simple hole, the second one was the contour hole. If in case you want to edit any of these features, like even the normal extruding as well, you have the option to double click on the feature, and you have the full control to change any value if you want. And once you change it, you would be able to click OK. Also, you would be able to go there, right click, and go to the edit parameters to be able to change the parameters in here. For instance, you can see I would be able to change the diameter of it to 10, and you can see the diameter will change in here and become to the 10. So let me bring it back to the 20. So that's the two type of that. Let's continue with creating the another hole. So still I'm in the general hole, and from the contour board, I'm gonna go with the contour side. and I'm gonna click on the specify point. I'm gonna click on the plane that I want to have the point there. You can see it automatically create a point for me. If in case I need more point, I would be able to click there. But I'm happy with just that point. I just want to use the dimensioning to put it into the dimension that I'm looking for. So this one, I will change that, let's say to 20. I'm gonna click on enter. And this one, I'm gonna change it to 25. And I'm gonna click on enter. I'm happy with everything, so I'm just gonna click on finish. And you can see the difference between this one with the contour board, so you have a taper angle in here as well. So the casing diameter, let's put it as the 20, for instance. Hopefully it doesn't meet the other areas. So basically I have to, yeah, 20 is fine. And you can see I got the error because this diameter, like before, should be smaller than this diameter. So let's change this one to the 15. So this diameter, like even the contour board, this diameter or even this diameter should be bigger than this one. This is how the software works. So on the C-sync diameter, I'm gonna keep it as a 20 because otherwise I think I will meet the other point. This C-sync angle, the angle we have there, I'm happy with the 90 degrees. So you can see here, this diameter, let me change this one and change it to 10, for instance. The depth of it, the total depth of this one, let me change it to 30, for instance. And of course, the tip angle in here. And again, like before, we have the option for cylinder button as well as the cone tip. Like before, it still is a subtract. And once I'm happy with everything, I would be able to click on OK. And you can see that I have the hole there. Again, let's have a look to see what's going on inside there. The cube that I have there, the block that I created. So you can see this one is a normal hole that I created using a simple hole, general hole. This one is a contour bore hole, and this one is a contour sunk that I just created. So let's go with creating one more, but right then I'm going to create one more. I'm going to edit the last one, the contour sunk one. So if I'm going to edit that, I would be able to double click on it, and still in a general hole, I'm going to change the contour sunk to the taper. And you can see into the taper, you still have the few dimensions you need to define. The first is the diameter on the top. Let me change this one to the 20. The taper angle, the angle you have here, as well as the depth of it. So I'm gonna keep the depth for 30, the taper angle for 10. And again, if I'm happy with everything, I just want to click OK. And you can see that I created the different type of hole. And this is what we've done. So let's continue with creating the different type of holes. So let me get rid of the holes that I created. And now I'm going to click one more time on the hole. And instead of going to the general hole, I'm going to go with the other time, which is a drill size hole. And again, like creating any other hole, like the simple one that we just created or general hole, you need to specify the point. I'm gonna click there, and I'm gonna specify the location of the point as well. So let me change this one to bring it to the middle. I'm gonna put that one as a 25, and this one, let me change it to 20, for instance. And once I'm happy with everything, I'm gonna click on finish. And the whole direction, I'm going to keep it as a normal to the face, so become like that. And you can see in here, there are some of the sizes that is already in the library of the software. And these are all standard version of the drill sizes, basically. So the one which is available. You can either go with the one that you're happy with it. So let me go, for instance, with the 3, and you can see that it visualizes it for you. For the fitting, you would be able to have it as an exact, or you would be able to go with the custom that you would be able to change the value of these, which basically you would be able to change the diameter, the depth of that one, and also the tip angle, whether you want to have the tip angle or you don't want to leave everything. I'm going to keep it as a 0. Also, the total length was 50, so let's change this one to the 30, for instance, as well. And this is if in case you want to use the standard version of that. Usually, if you work for the small, medium-sized companies, they prefer to go with the standard version of the holes, for instance, or the drill bits, because it's cheaper to manufacture, is available to the market. However, if you work for the big companies, it's quite well known in the big German kind of manufacturers, they prefer to have their own kind of customized tooling sets. And there are a few reasons for you as a designer. First of all, you as a designer would have much more freedom in order to come up with your own kind of design, so you're not limited to the one which is available as the standard tool sets. And also, it's really hard for a gray market to be able to replicate, to be able to copy your design, because it's really expensive for them to come up with their own kind of customized drilling, for instance. And it's the same thing for any other market as well. We can see these is Apple use their own kind of customized tooling sets, which is really hard for the unauthorized after sales support to be able to actually come on and service your product. So it's really hard for them. They have to buy the kind of customized tooling set, which usually these companies don't sell it, so they have to have a company to be able to actually manufacture something like that, which all these sort of things would be able to give much more freedom to the company to make sure they will take care of the after sales directly by themselves. So let's say I'm going to go with the default one. I don't want to have any customizing sets, which I've done. I need to just change this one to go to the exact, which basically whenever I change these, the diameter value will just keep changing. And then I just need to change the depth of it as well. So these things, these are not the standard. I would be able to actually control that. Once I'm happy with everything, just wants to click on OK. You can see it's created the drill size hole for me here. And if in case I go with the static wireframe, you would be able to see it there. And this is all standard drill that I just created, the drilling hole. So let me go back and bring the shades back. Let's go and create another hole. So what we've done the general hole, we've done the drill size hole. Let's go with the screw clearance hole. So again, I need to specify a point. I'm going to click there. And you can see the point has been created. I'm going to put the dimension for it. And I'm going to use the rapid dimensioning. Put the dimension between the point and to the side. And I'm going to put that one as, let's put it 50. And I'm going to continue with just putting the dimension between these two as well. And I'm going to put that one as the 25 to bring it to the middle. And I'm going to click on close and finish. So I'm going to come out of the sketching. And in here, again, like before, I have the form as a simple. I can have it as a counter board. I can have it as the counter song. So basically the tip off and the opening of the hole will change. I'm going to go with the simple first. And again, in here with the screw type, I would be able to use the different kind of screw sizes in here. You can see again, I would be able to load the library and use those which are available. Let me go with the MH. The only difference here in the fit, we have different options. I can have it as close as possible. So you can see it's an 8mm screw that I have. So the diameter of the hole that I'm going to create, the software tells me it would be 8.4 if I go with the close. If I go with the normal fitting, which basically is a 1mm gap and 1mm clearance. If I go with the loose, basically they're 2mm and that becomes loose. And of course, I would be able to customize it. I can go and put the exact 8mm, which is almost impossible because of course you should have some sort of clearance. The clearance is really important. You need to, because basically the kind of clearance you put, it will impact amounts of on the final tolerance analysis, because it depends on how much pressure that as a result of the screwing the screw will impact up to the rest of the body of the block that we have here. So this is all different kind of customization you would be able to have there. And I'm gonna go and put it the normal one. I'm gonna let the software to choose the clearance for me. I'm gonna put the depth. Let's change this one to the 40, and also the tip angle. Again, you would have the option to either put that one, or I can put it as the 0 basically in here, and that's the other type of it, and I'm going to click on OK. So you can see all of them, they are almost like each other, and the only kind of things is just a few parameter will change. Let's go and create another hole, and this time I'm going to go and use the threaded hole. So like before, I'm looking to specify the point. I'm going to pick up the plane that I'm going to have the point. I'm going to put the dimensions because I want to locate the point in the middle. Let's put this one as a 25, and even this one to the side, let me put it as the 25 as well. Good. And once I'm happy with everything like before, I'm going to click on finish. And again, you can see here, I would be able to load these information, the threaded hole, using the library that I have. I would be able to change these to what I'm looking for, which basically is the diameter of it and also the pitch angle of that. So also here with the depth, I would be able to go with the standard version, which is the 1.1 times of the diameter, 2 points of diameter, for instance, the 3 times of diameter, or even if I want, I can go with the custom one and I would be able to put the value in here. Let me put the value of the 30, for instance, in here. And also these things, this is really important. So this is the thread depth, which basically is some part of the total depth you have. So for instance, let's say I have 40 millimeter depth in here, and 30 millimeter of that one from the top would be threaded, and the rest, they are normal. If in case you want to have a fully threaded, I need to put these equal than each other, and I cannot have the total depth lower than this amount. Let's have a look. If I do it like that, you would be able to see here that it says the whole depth must be greater than the thread depth. So the software is smart enough to tell you that information. And again, same as before, I can put the tip angle, or if I don't want to put anything, I would be able to put 0, and I don't have anything here. So this is if in case you want to use the kind of, from the library, basically, you would be able to put the values in here, and I can see it's a wide range of the numbers that is available in here, which you would be able to use. Also in here, I would be able to then change the drill diameter. You can either go with a radial linkage here, which is 0.75 or 0.5. These are all standard. If you want to have the customized one, basically you can put it as a custom and change the values in here. If in case you're happy with everything, you would be able to click on OK. Something if you notice there, although this one is a threaded hole, you don't see any kind of thread inside. This is how the NX decided to put it, which basically is the simplified version of the threaded hole in visualization. But once you will take it to the technical drawing, it automatically realizes that's a threaded hole and mark it as a threaded hole. But in order to make it easier to the assembly, for instance, they decided to get rid of just the visualization of it. But basically, still is a threaded hole. And this is something usually the student keep asking me, what's the difference between this one? Because into the other software, once you create the threaded holes, you have some sort of visualization of the threads inside. And that's a correct way of making the threaded hole. However, if in case you want to make it kind of in a thread, I'm going to show it to you in a bit, but this is not the correct way of making a threaded hole. This is just if in case you want to visualize it, or if in case you want to have a thread, but not as a threaded hole. So let's have a look to see how we'd be able to create that one. So let me bring it back, the edges. And so let me get rid of these. Good. So before I go with the threads, how we're gonna make it, let me go and create one more type of the hole, which is remained, which is basically the whole series. Let me go with the whole series. Again, I have to specify the point. I'm gonna start with that point, so I don't want to dimension it now. It's okay. And you can see by creating the whole series, you have the 3 different areas to specify. You would be able to specify the start. So I would be able to specify the start. You can see I can have it as a simple the counterbore, countersunk. Let me go with the countersunk. And again, I would be able to change the screw size in here, for instance. Even the fitting, I would be able to go with the close, normal, loose. Let's go with the close, for instance, on the top. In the middle, I'm gonna change the type of this one. So if in case you want to continue with the match dimension to a star hole, basically will continue straightforward without any changes. If you untick that, you will start with a close. I'm gonna go to the normal. So this one become a normal fit. And also onto the end, I will be able to change this one and put the loose, for instance, even tip angle. Let's change it to the 0. Let's change this one to the 30. So we use the whole service if in case we want to have the full control of the 3 different areas of the hole that we're gonna create. And it's a really useful tool, so which gives you much more freedom in case you want to have the 3 different areas of the hole that you created to be different. Great. So that's regarding this part. Let's go and talk about the threads. How would be able to create the threads. So let me get rid of these first, the block. And what I'm gonna do, I'm gonna make a cylinder. So I need to go to the sketch, click on OK. I'm gonna pick the XY plane that I have. I'm gonna make a normal circle and put the diameter of the 25. Enter. I'm happy with everything, so I'm gonna click on the finish a sketch. And what I'm gonna do, I'm gonna extrude it, pick this one up, and let's put the extrude of the 100. I'm gonna click on OK. So you can see what I've done is the normal cylinder I just made with the diameter of the 25 and length of the 100. So now what I'm gonna do, I'm gonna apply the thread on it. So in order to find the thread, I can go to the more. You can see here, you will be able to find the thread. And of course, if in case you don't know where it is, you can always go to the command and then type for thread, and it will tell you where it is and how you can find it. So you can see to the threads, there are the 2 different type of it. A symbolic, which basically the symbolic, the same as what we created the whole, it doesn't visualize it for you. Although whenever you go to the 2D drafting or technical drawing, the software realizes it automatically and recognizes it as a thread, but it's not visualized. If in case you want to visualize a thread, you need to go and pick the detail. So with the detail, you can see the values, they're all 0 right now because I haven't specified where I want to have the thread. What I need to do, I need to come to where I want to have the thread. Let's say on the outer area of this cylinder. I just need to click once, and you can see it automatically got the dimension, the diameter, which was 25. So it says the major diameter is 25, therefore the minor diameter as a recommendation is 23.5, but of course you would be able to change it. The length of it, whether you want to have it as a full thread, it's 100. Let's go with a half thread, which basically 50. So up to the middle of it is threaded, not the rest. The pitch angle is 1.5. Let me change it to the 3, for instance. The angle of it's coming. So let's keep it as a 60 if in case you want to change it. But of course, where to start? So I'm gonna start from the top. What I need to do, I need to click on the select start. I'm gonna pick that plane. I'm happy with everything. So to extend through the start, it comes from the top. I'm gonna click OK. I'm gonna click OK and let the software to generate it for me. So you can see I generated the threads from the top to half of or to the middle of this cylinder. If in case I want to change any of these values, I would be able to double click on the thread like before and go to the feature dialog and change these. Let's say I'm gonna change the length and make it as a fully thread. I'm gonna click OK and OK. I'm gonna let the software to generate it for me, so we can see I have a full thread in here, and this is how I would be able to generate the detailed thread. If in case you want to have a correct thread, basically you can see the ending, it doesn't finish completely. Sometimes in the design, it's really important to make sure actually your thread would be fully finished. And I've noticed in some of the kind of exams for the CAD, it's really important. They would deduct marks if in case it's like that. If in case you want to get rid of that part which is not a fully thread, it's really simple. What you need to do, you need to come and edit this thread, go to the feature dialog and increase the length. So the full length is 100. Let's increase it to the 102, 101, 1 mil, 2 mil, more is fine. And if I click OK, that's a software to generate. You can see I have a fully threaded cylinder. So even this one, it completely goes and finishes. This would help me if in case I want to use a threaded bolt or something like that for the assembly. It would be quite easier to deal with something like that, which is the fully threaded. So this is how you want to create a thread on the outer side. Let me go and create a thread into the inner side of this one. Let me get rid of the thread that I just created. So like any other feature, I can right click and click on delete to get rid of that one. And what I'm gonna do, I'm gonna make a cut into the middle. So I'm not going to use a hole. Usually, as a correct way, it's just creating a hole. But I'm gonna tell you how usually the students do this one, which is incorrect. So what they do, they go and create a sketch. Click here. Click OK. Let's make the a circle there with the diameter of let's say 18, for instance. And I'm going to click on finish a sketch. What I'm going to do, I'm going to go to the extrude, pick this one, and bring this one down. What I can do, I can put the value as a true all, goes to the end, and the boolean becomes subtract basically. I'm going to click OK. So you can see what I've done. I've done a cut. It's absolutely fine. There is nothing wrong with it. But once I go to the 2D drafting and technical drawing, because I'm going to use the software to automatically generate that one for me, it wouldn't realize this one as a standard hole or as a hole. It just shows it as a cut, which sometimes will cause you a problem unless you come on and update it manually. So that's why whenever you're going to create a hole, make sure you go there and create the hole by using the hole feature. The same thing even for the thread. If I'm now going to go to the thread, I would be able to pick the area I want to have the thread. This time is the inner part. So the major diameter was 20, if you remember. The minor diameter is 18. It's automatically realized it. This circle was 18. The length, let's go with the pitch angle, the angles, whatever you want to change. We can change it here. Let's select a start. I'm going to start from the top. I'm going to click OK. I'm going to click OK. And let the software to generate that one for me. And you can see I created a thread inside. And this is what the usually students does. And once they go to the 2D drawing or technical drawing, as well as the assembly, to be honest, they cause problems. Because basically what they've done, they manually went to the extrude, make the extrude subtract and apply the thread, whereas easily they could come here, go to the hole and change the type and go to the threaded hole. Of course, it wouldn't visualize it because this is how the NX decided to go with the symbolic rather than the detailed one, but it's absolutely fine. So what I recommend, don't go and use this one. Go and use the proper and standard version, which I just mentioned it to you earlier as well. But again, this is the another way if in case you want to go and see the thread inside. This is how you'll be able to do it. But of course, this is not the appropriate way of doing that. If in case you want to see the difference between this one, which is a detailed thread, and you would be able to see the visualization and the symbolic one. So let's have a look to see what's the difference. Let me get rid of that. And what I'm going to do, I'm going to go to the thread. And this time rather than detail, I'm going to go with the symbolic. I'm going to pick the inner part again. So you can see the major diameter is 20, the minor one, it automatically detects it. I can define the pitch, the angles, even I can change this one. So you can see you would have access to the table to change it to the different kind of standard ones. Even if you want, you can click on and go and put the manual value. I prefer to go with the standard one, but if in case you want to go with the manual, once you tick that, you have a full control of this information. And again, like before, I can select the start. I'm going to start from here. I'm going to click OK. I'm going to click OK. And what you can see here, basically, you would be able to see that I generated a symbolic thread, but it's not visualized. So you can have a look here. Still, it works fine, but the thread is not visualized, and that's why we call it a symbolic. And that's the difference between the symbolic one and the detailed one. And this is how the NX usually works. For the hole ones, we go to the hole and use the threaded hole. Basically, from here is a type of the symbolic, so it doesn't visualize it, but nothing wrong with it. Don't worry, because once you use the 2D drafting, it realizes a symbol as a symbolic thread, as a thread, which is why you see it in here as the a thread. But again, if you, in case you want to visualize it, you have to go with a detailed thread. So let's go with another feature. Great. So let's go and learn about the different feature. It's called group. In order to do that, what you need to do, you need to go to the command and type for groove and click on enter. And you can see the groove is currently hidden because there are different ways that would be able to generate it. But of course, I prefer to use a groove because it's really a straightforward feature to use rather than going to the different kind of sections by using the extrude and extrude CAD. In order to find it, you can go to the menu, insert, design features, and find the groove there. But of course, it's really easier to go to the command finder and search for it. For the groove, there are the different type of it. We have the rectangular one, the ball end one, and the U groove. I'm gonna go with the rectangular one. And I need to specify where I want to have that groove, basically. So I'm gonna pick up this area, but I want to have the groove. So the groove diameter, I'm gonna put it as the 50, and the width of it, I'm gonna put it as the let's change this one. I don't know. Let's put it as the groove diameter. Let me put it as a 25, and the width of it, let me put as 50 to have a look. And I'm gonna explain those information. So what I need to position the groove. You can see that in here, also in here it says the feature position is under specified that I need to do. And also in here it says select target edge or OK to accept the initial position. So if in case I want to change the position, I would be able to choose any of these edges first, the other edge, and I'm going to pick up this one and put the distance between these two. So I'm going to put that one as 30, let's say. I'm going to click OK. So you can see, and once you're happy with everything, basically just click on cancel. And this is, you can see how I created the rectangular groove, which the information that I provided, if in case I want to see it or edit any of these features information, I can go there, go to edit parameters, but of course I can double click on it. I can go to the feature dialog, and you can see that the information that I put there is, this one is 25, basically the groove diameter, and also the width of it, that I have. So let's change the width of this one from 50 to 30, and let's change this one, the groove diameter, from 25 and to, let's say, 20, for instance, and click OK. And I would be able to click OK, and you can see that's the difference between what I created. If in case I want to change the position of that one, what I would be able to do, I need to go there and go to the edit positioning. And in here, I can put the edit dimension value. If you remember, from the distance to here was 30. Let me change this one and change it to the 40. And if I click OK, you can see it bring higher, because that distance to there was 30, and now that becomes 40. So that's the rectangular groove, if in case you want to make it. Let's go and see the other type. So let me first bring this one down a little bit, because what I'm going to do, I'm going to have all those grooves next to each other, so hopefully it would be easier to understand them. Let me change this one to 10. I'm going to click OK, so it comes there. So the other groove, let me search one more time for groove, click there, and I'm going to use the ball end this time. So like the previous one, I need to specify where I want to have that groove. I'm going to pick here. And the groove diameter, the ball diameter I need to put. So I'm happy by going to the 25 groove diameter is okay. Let me change the ball diameter to 20, let's say. I'm going to click OK. And again, I need to position it again. So I'm going to put the distance between this one and this one. and I'm gonna put as 20. I'm gonna click OK, and once I'm happy, I'm gonna click on cancel. So you can see the difference between the rectangular one that I just created and the ball end is basically, this one is like a rectangle, goes inside and cut it, whereas here is like a ball that goes there and then cut the area. Like the previous one, if in case I want to change any of these value, let me go for instance to change the position of that. I can go and click on edit positioning. I'm gonna change the edit dimension and I'm gonna bring that one and change it to the 5, let's say. So bring it to quite close to the other area. So let's go and see the other type of the groove. So let me again go to the groove one more time. And this time I'm going to go and pick the U groove. I need to choose where I want to have the groove. I'm going to pick that area. Groove diameter 25, width 20, even corner radius 2.5. I'm happy with those information. I'm going to explain in a second. Basically, the corner radius is like a corner of the U shape. And I'm going to click on OK. I need to position it. This time I'm going to position from the top. So basically from here to here. And I'm going to put the distance, let's say, of 5. And I'm going to click on cancel. So basically what you can see the difference here. Here was basically like a rectangle goes and cut it. Here was like a ball goes there and cut it. Whereas here for a U is basically like a U go there and cut it. And the information that I put for the corner is basically that 2.5 is here. So the corner of the U is basically control that. Here the groove diameter 25 is this one. The width of it is this one. Here is 2.5, and also the positioning was basically the position from the top that I put. And this is what we can see for the groove. Is a really useful tool. And although there's a different ways that you would be able to do it, for instance, through the cut, but of course here it would be much more easier, much more professional as well, if in case you want to use the grooving. So let's see the other features as well. Let me get rid of these first. And what I'm going to do, I'm going to create a extrude rectangle by using the block again. I'm going to put the value of the 100 by 150 this time. I'm going to click on OK. And now what I'm looking to do in here, I'm going to go and use another 3D feature called a slot. If I search for that, you can see that you would be able to just find it in here. But again, next to it is written as a legacy, which basically the NX decided to keep it, but no longer have it visible to the designers unless you're looking for it, because there's a different way that you would be able to use a slot. It's quite well known if in case you're familiar with the CATIA or SolidWorks, we use a slot a lot over there. But of course, you would be able to do the same thing using Extrude, and I'm gonna show them both. But if in case you're gonna use a slot, which I recommend, you would be able to just go to the command finder and search for it. I'm gonna click on slot here. And again, there are the different type of it. Let's begin with the rectangular one. What I want to do, I'm gonna pick the rectangle and click on OK. I need to specify where I want to have it. I'm gonna have it on the top. And what I need to do, I need to have a horizontal reference. You can see here, even it says select horizontal reference. I'm gonna pick that edge as the reference. So the direction of the slot would be like that. So the length of it, let me go with the 20. The width of that, the width of it basically is, let me put it as the 5. And the depth of it, let me put it as the 10, for instance. I'm gonna click OK. So you can see it's trying to make the outline of that slot for me. And I need to position it. Basically, I need to position that one because I would be able to move it around. And these are the different ways. You can use the horizontal positioning, the vertical one, the parallel, perpendicular, the parallel at a distance, the angular one, and so on. I'm going to go and pick the perpendicular one. I'm going to put the dimension between these two. I'm going to put that as the 20, let's say. and I'm gonna use it one more time, but this time would be this edge with this line. I'm gonna put that one as 50, let's say. I'm gonna bring it to the middle. I'm gonna click OK, and once I'm happy with everything, I'm gonna click on cancel. So if in case I'll go to the static wireframe, we can see how the slot is being created. Basically, you have the shape on the top and it's been extruded using the extrude CAD, and the material has been removed basically using the subtract. The slot is quite well known. The reason for it, because it's really a straightforward one and I could easily do it one more with one basically a feature. If in case I want to use any of these parameters, I would be able to go there, double click or right click and go to edit parameters. I can go to the feature dialog, change these values. Let's see, for instance, I'm going to change the width to the 10. Click OK and click OK. So you can see now the width is become bigger. If in case I want to change the position, I can click there and change the position of this one. For instance, I can change the value of, let's say, this one to the 25, for instance. Click OK. 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 You can see I changed the position of that one. So you have full control of what's going on. The reason that NX decided to get rid of it or keep it as a legacy that still is available but it's hidden, because what I can do, I can go to the sketch. I can pick the plane that I want to operate. Let's say I'm gonna pick this plane, make sure it's on the top, yes. And I would be able to make a rectangle. I'm not following the exact dimensions, but of course you can do it. And what I'm gonna do, I'm gonna make an arc between these two. Gonna have it there, and I'm gonna do the same things there. And I need to get rid of those two lines, so I'm gonna go to the quick trimming, get rid of these two, close, finish the sketch, go to the extrude, pick the curve that I have, make sure it's subtract. I'm gonna change the direction of this one, put the value I'm looking for, and click OK. So you can see the end result will do the same. If in case I follow the exact dimension, will do the same. But the sequence of what I've done, the number of tasks I had to do, for instance, in a sketch, what I've done, I make the rectangle, I make the two arcs, I use the trimming, then I went to the extrude, then I applied the extrude. Whereas easily, I could use the rectangular slot in order to achieve the same result. Of course, this one, if in case I want to use the sketch on extrude, you don't need any familiarity with the 3D features, and that's why it's more kind of simple. But of course, as a professional CAD designer, you want to use the kind of all the features which is available for you, more kind of advanced features, in order to save time, in order to do things professionally, and that's why I recommend in this case to use the rectangular slot. So let's go and use the other type of slots as well. So let me get rid of the sketch and extrude that I created. So what I'm going to do, I'm going to go to the rectangular slot this time and go and open the feature dialog. As you can see here, I would be able to control every single of those here. But if I go and click on the change type, you can see I can see the other kind of types available. I'm going to still use the rectangular, but this time I'm going to go and use the true slot. And if I click OK, I need to say where to start from and where to go to. So I'm going to have here as the start. I'm going to have this one as the ending. And I'm going to click on OK. And you can see it's basically like a rectangle that goes and cut from this face and go through the other face. And that's the rectangular slot as a true. So let's change the type of this one. Let me go there, go to the edit parameters. Let me change the type of it and go and change the ball end. So it's like the grooving basically with the ball end. It's like a ball that goes through. You can put the ball diameter, you can put the ball depth. And once you're happy with everything, you would be able to click on OK and OK. And you can see it's basically like a ball that goes inside and cut it. Like before, if in case you want to change the parameters, you can go there, go to the feature dialog, and you can see the dimensions here. That one is a 10. Also, the depth of it is 10 as well. So let me change the type of it now to the U slot. It's basically like a U shape to go and through and cut everything. You would be able to define the width, the depth, as well as the corner radius, the radius there. And if I click OK and OK, you would be able to see the U shape. So basically the corner that I was talking about is in this area, the kind of U area of it as well. Let me change the type of it again to the T slot. So within the T slot, you have the top width, you have the top depth, the bottom width, and the bottom depth, because you want to make a T shape basically. And if you're happy with everything, you click on OK and OK, and you can see basically it's like a T that goes through and cut everything for you there. Also, let's go and try the last type as well, which is a dovetail. You can click on OK. Again, you put the information there. Gonna click OK, and you can see this is kind of in a dove shape style as well, and a dovetail. And you can see it here. So it's really a straightforward and it's really useful tool to use. So let me get rid of this one. So the other feature I'm going to teach you here is calling the edge blend. So the edge blend is basically like a kind of face blend that we have it in, or face fillet that we have it into the CATIA and SolidWorks, and we're gonna have it into the edge blend. Basically, the edge blend is the same as what we've done into the 2D sketching using the fillet, but in here is through the 3D model. So in order to find it, you need to go to the edge blend. Basically, it's into the common features. Just need to click there. And in here, you need to specify the edge you want to apply that blend, basically. Let me click this edge. And you can see in here, you would be able to give the radius. We have the different type of it as well. We have the tangent one, which basically the curvature become a tangent using the G1. And it can be the curvature. So the curvature, you have the different value as well, which you would be able to control the other parameters as well. Let me go with the tangent. Even with the tangent, you have the different option. You can make it as a circle, or you can basically have it a kind of conic blend, which basically make it like kind of in a cone. I'm gonna go with the circular one, and once I'm happy with everything, I'm gonna click on OK. So this is how I created the edge blend for just one edge. If in case I want to edit that one, I can go there and edit a parameter. I can change the value of that one. Or if I want to apply the edge blend to the different edges, I can apply this blending for all edges that I'm looking for at just one click. So basically, I can have it in here, I can have it in there, and I can have it in there as well. For instance, let me click OK. And you can see I applied the edge blend in all the edges that I was looking for using the one simple feature. Let me go there and edit this one. And what I'm going to do this time now, I'm going to make the sets. With the sets, I would be able to use just one simple edge blend that I've used, but now with a different value. So the first one, if you remember, was 5. And now this one, I'm going to change that one to the 10. I'm going to click OK. So you can see still I use one simple feature, and within that one, I have the filleting to the face, but with the different values. Some of them there are 5, and some of them there are 10. You can see here these are 10 and these are 5. And this is how you would be able to using the set parameters. Basically, I can click one more, and let's say this time I'm gonna have this one as the 20, for instance. I'm gonna click OK. So you can see rather than I have the series of these edge blends, which I basically could have a few of them, I apply everything within one simple feature that I've applied for. Also, if you go to the edge blend, there are the few more parameters you would be able to work. If you click on here, you can see the different things. So you can have the variable radius, which basically with the variable radius, what you have there, you can see that at the start with the end of the blend they have the different radius. If you go to the corner setback, which basically around the corners, the corner that we have here, I would be able to specify a point. Let me do it here. I would be able to specify a point, and within there you have a full control to have the different kind of radius in here. So basically here was 5, and then in here you can have a control on every single of these. So for instance, this one is a 2.5. I can have this one, I don't know, as 4. keep that one as a 2.5 and then keep this one and change it to the 3, for instance. So you have a full control of what's going on around the corner. You have the lens limit, so which basically you can apply the limit to it. Also, you have the stop through the corner. So rather than having the blending for the full of the edge, you can have it as a start if you remember at the beginning and also the end. So you don't have a fully blended edge. And all these things, you can take some time and familiarize yourself with. This one is a really simple and useful tool. So this is the other thing I wanted to mention. Again, as you might ask, for example, this key, what you could do, basically you could go to the 2D sketch and apply the fillet and then extrude it. So let me quickly show it to you. So let me get rid of that. And let me get rid of this block as well. So basically what I can do, I can go to the sketch, XY plane. Let me make the rectangle here. And then come out of the rectangle. I can easily go there and pick up the fillets. And again, have the fillets, let's say 10 is okay here. And again, continue and then have it in here as well, 10. I'm gonna do it in here as well. And then do the 10 here as well. And once I'm happy with everything, what I'm gonna do, I'm gonna extrude that. And you can see I still got the fillet through the edge. But again, if in case I haven't done it, let me go back to the sketch. Let me do a Control Z, get rid of the fillets. What I could do, I could come and extrude this one. And then come to the edge blend and apply the fillet for the value of the 10. It's completely the same things. This one I prefer because it's more straightforward. And this is what you can do. You can either do it within the 2D level, 2D sketching, or within the 3D level or 3D sketching. So let's go and learn chamfer as well. So in order to find the chamfer, you need to come here and next to the edge blend, you can see the chamfer. For chamfer, you need to specify the where you want to operate. Let me get rid of the edges on the side so we can apply the chamfer there. So what I need to do, I need to go to the chamfer, unlock the edge blend. Again, you need to specify the edge you want to have it. And again, you need to put the value of it. You can have it as a symmetrical, asymmetrical, which basically have the different distances. You can have, I don't know, one side as a 5, the other side, let me put it as a 10, for instance. You can see that you have full control of that. Even if you would be able to bring an angle to it. If you go to the offset angle, I would be able to have an angle as well to have a control of the angle of the chamfer as well. And again, if you want to have a symmetrical chamfer, you can go there and click OK. Again, if you want to have it under the multiple edges, you can come there, edit it, and you would be able to apply it into the other edges as well and click OK. As easy as that. And again, like the fillet or the edge blend, basically you could do it into the extrude level as well. Let me get rid of this one. And if you remember, I could go to the sketch. And in here, I could go to the chamfer and have the chamfer, let's say, between these two. And there, a chamfer of 10. And this one should be 10. I don't know why it didn't pick it up, but it's the same thing. And what basically happened, I can go and finish the sketch. And it's the same thing. I can either have it as a 2D level or as a 3D level. Both of them is correct and there's nothing wrong with it. So that's it for this part. Let's go and find more 3D features we're gonna work together. The other feature I want to teach you is called rib. Rib is quite well known, especially in automotive. In case you want to make a cylinder, connect them together, it's quite well known. So let's learn rib as well. It seems to be a little bit tricky, but once you learn it, it will be a really useful tool to work. So what I'm going to do, I'm going to use a rib function, which basically connects a rib from this edge to the cylinder that I have. cylinder that I make using the block and extrude. So what I need to do, I need to go to the more and look for the rib, which is, you can see, one of the 3D design features. But of course, if in case you cannot find it there, you can always go to the command finder and search for the rib. If you noticed, for the rib, I need to have a target, a select body, as well as a sketch to be able to connect these together. But if I go to the sketch, first of all, I won't be able to sketch anything in the middle. So therefore, I need a plane in between. And then, of course, I need to see how I'll be able to connect the line from here to there. So let's have a look. First, as I mentioned, there's a problem, and it's basically, if in case I do any kind of sketching, I'm limited with these faces and I don't have any kind of plane in between. So in order to do that, I need to have a plane. I need to create a new plane. So I need to go to the datum plane, click on there, and there are the different type of it. What I'm looking for here is a bisector, and I want to create a plane between this one and this one, and click OK. And you can see I created a plane exactly in the middle. But there is another problem as well. If I go to the sketch and I'm gonna pick that datum plane to sketch, I want to create a line from here to the cylinder. But there's a problem here. Unfortunately, I won't be able to make a connection to the cylinder. So in order to do that, what I can do, I can come here and use a 2D sketching feature called intersection curve. If I open this one, you can see there is a section there. It's called intersection curve. And within the intersection curve, let me put it into the 3D mode. I'm going to select the cylindrical part. Let's have a look. What happens is it automatically realizes there's an intersection between the plane that I just created and the cylinder and make it a line in between. So now it will be quite straightforward whenever I created a sketch to connect the sketch that I have from here to there. So that was the first step I'm supposed to do. I'm going to finish the sketching. So the first thing I'm supposed to do was creating a new plane. Secondly, I'm supposed to do an intersection curve. And now let's go to the rib one more time. So if I go to the rib, you can see the target body is 1. If in case you don't see it as the 1, it might be because once you create that extrude, it's not using the unite boolean, which means it's separated from the first kind of 3D geometry that you have. And if you go to the rib, you can see that you will end up to having just one single body and they are different. So it's really important. All of the 3D features you're using, you're connecting them together using unite. This is something that we mentioned into the last session as well. So let me go back to the rib. I've done the plane, I've found the intersection, and now I'm going to use the rib function. So I have the select body, and into the section, I need to create a sketch. I'm going to click to the sketch section. I need to find a plane that I want to sketch. I need to pick up the plane that I created in the middle. I'm going to click OK. And what I'm going to do, I'm going to make a line from here. Let's connect it to anywhere you want. Of course, you can position it, but I don't mind it here. I'm going to click on finish. So what you can see, I could generate a rib in between. And of course, I can change the value of it. Let's change the value of that one to the 20, for instance. I can see the result there. These are the different type of it. I can have it as a symmetrical, which basically have the same value on the both sides. I can have it as the symmetrical, which basically you will ended up by having into the one part of it, either into the right or either to the left. Of course, I'm going to go with the symmetrical. Let's go and make it that big as well and click OK. So you can see it's quite simple, but these are just few sequences that you have to follow, but this is one of the ways that you would be able to use the rib to connect them together. But I'm going to show you how we can use the ribs using the kind of like the flooring into the block or into the cube as well, which we're going to go through it in a second. So let's using the rib 3D feature to make the flooring and wall, basically for the shell that I just created. So in order to do that, we need to go to the rib, and again I have to have a sketch. But again, the sketch I need to make needs a new plane. So what I need to do, I need to come out of the rib, go to the datum plane and create a new plane. Using again the bisector, I'm gonna make a plane between the top and the bottom of the cube that I have. And I'm gonna go to the rib one more time. And this time I'm gonna click on a select curve. I'm gonna click there, and I'm going to pick up the plane that I have. Click OK. Bring the sketch into the middle. I'm gonna, let's say we're gonna make a rib which gonna connect this one to there, and from here to the top. So horizontal, vertical, great. I'm gonna finish. And you can see that I created the a rib. I can control the thickness of that one. Let's change it to the 5. I can have it as a symmetrical basically. And even I can have it as a parallel to the plane. So basically parallel to the plane. I can have it as a perpendicular. But the software is quite smart enough. Let's say I have the 2 curve. And let me pick up one of these curve and just pick this one. So what I need to do, I need to come here, go to the curve, and here I'm gonna go and use only single curve. Pick this one. You can see we'll connect the full wall. The same things even in here, the full floor or full wall. But if in case I'm gonna pick both, I can go and pick them both and then have the ribs like that. So what I've done, I went to the filter, make sure the curve is selected. Also in here, usually we have the connected curve, and I change to the single curve if in case you want to have just one of them as the fillet, as a rib, sorry. So this is the ribs, and as I mentioned, it's quite a useful tool, and hopefully it was useful. So today we learned a few different kind of 3D feature using the Siemens NX, and now let's put them to the practice with the different tutorials. I'm gonna upload the tutorials into the separate videos, so that would be easier to go through them and pause and practice at your own time and come back and watch the rest of it. Thank you so much, and see you into the next video. Thank you.